Cool.
Hello, welcome back. In this video today, we're going to look at a topic of assignment problem. So remember in our previous discussion, we did what we call transportation problem. So today we are going to look at assignment problem. It is still a linear programming problem. And in the transportation problem, we learned about how goods can be moved from one destination to another. But this time round, we are looking at how services can be moved from one location to the other. So in this transportation problem, we are going to use a method known as the Hungarian algorithm. So we're going to use what we call Hungarian algorithm. That is the method we are going to use to solve the transportation problem. So I'm going to give you the problem that I have written here. So this is the problem that we have. I'm going to read to you how the problems look like. Now, service engineers or a company employs service engineers based at various locations throughout the country to service and repair the equipment installed in customer premises. 4 requests for services have been received, and the company finds that 4 engineers are available. The distances each of the engineers is from the various customers is given in the table that I've given you here. So this is the table. So we have the customers. These are the customers. We have Alf, Bill, Charlie, Dave. Now we have the engineers now based in different destinations. We have let's say Wilson, so forth. Yeah, we have W, X, Y, Z. So these are engineers. I've just called them that, and they have to go to machine and maintain, or to maintain the machine at different destination, different customer destination. So we have the miles. So this basically refers to 25 miles. For example, if engineer W have to travel to customer Alf, so he'll have to travel 25 miles. Also the other one you see, the same for all the engineers. So basically, this assignment problem wants to assign the engineers to the nearest customer possible, so that the company minimizes the total cost of traveling from maybe the company premises to the customers. So for us to solve this problem, as I've said, we have to use what we call the Hungarian algorithm. I'm going to take you through how the Hungarian algorithm goes through. Now, in the Hungarian algorithm, we have 5 procedures or steps that we're going to follow in solving the problem. So the first step is about what we call column and row reduction. So in each column, of course, you know we have a matrix already. We're going to find the smallest value. Okay, we start by doing what we call column reduction. So we find the smallest value in each column, and then reduce that value from all the values in the matrix table. Secondly, we're going to perform what we call row reduction. So in the row reduction, we are going to, after finding we're reducing the columns, we now do the row reduction by subtracting the minimum values in all the rows by the values of this matrix. Now, the second step, after finding the column and row reduction, after doing that, we cover all zeros with minimum number of lines. So we're going to cover all zeros with minimum number of lines. Then this one will take us to step 3. So in step 3, we confirm whether the number of lines equals the number of assignments. For example, in our case, we had 4 assignments. So we have 4 customers and engineers are 4. So the assignments are basically 4. So that means the number of lines represents the assignment. So in this case, we make sure that if all the number of lines are equal to the number of assignment, then in that case, we will proceed to the final step, which is step number 5. Now, if the number of lines that we have covered those cells in the matrix with is not equal, then we proceed to step number 4. So in step number 4, we perform the following procedure. The first one, if the number of lines is not equal, so step number 4 is here. So we find the minimum value of uncovered cells, and then let's call it X. So we see the cells which were not covered by lines, identify a value there which is minimum of all the values. Let's call that value X. Now, what you need to do now, you need to add this value, this minimum value x, to all corner points. That means all values which are covered by two lines. That's what we are referring to as corner cell or corner points. So any value there, you add the minimum value, then subtract this minimum value from all the uncovered elements. So reduce it from all the uncovered elements. Finally, all the values covered by one line will be left untouched. After doing this, step number 4, we proceed to step number, we go back to step number 2. So proceed to step number 2. And repeat the procedure until you realize that the number of lines equals the number of assignments. So in this case, we will proceed to step number 5 when the number of lines equals the number of assignments. Now in step number 5, we'll perform two simple procedures. The first one, we will assign to any 0 which is unique to both column and row. So in that scenario, we are going to do what we call row and column scanning. So after doing that, we will allocate a 0 in the row or a column which is unique. Then thereafter, we cover those, or maybe we cancel or we ignore all those columns or rows which have already been allocated. Then from there now we repeat the same procedure, doing column and row scanning. So we're going to understand better when we solve this example. So I want us now to go through the example and see how we're going to solve that. Alright, step number 1. So I've said we do what we call column and row reduction. So I'm going to draw another matrix here. The same matrix. Let me call these customers, or I have A, B, C, and D. Then I have the engineers here, W, X, Y, and Z. So I'm trying to find a new matrix. Alright. So I'm going to perform now what we call column reduction. Column reduction. So this is my first step. Under step number 1, so we do column reduction. So what we say is we find the minimum value in each column. So I come here and say, what is the minimum value? All right. So the minimum value in my matrix is simply, so you can see we have 25, 38, 15, and 26. So 15 is the minimum value. So here 15 again is the minimum value in this column. So here I have 23, 53, 41, and that's 6. 23 is my minimum value. So I have 14, 23, 30, and 29. So 14 here is my minimum value. So these are the values I'm going to use to get to the next matrix. So let's subtract. So we have 25 minus 15. I'll record here. So I'll have 10. 38 minus 15. So we have to work with our calculator. So let's see values we're going to get. So I have 25 minus 15, of course, that is 10. 38 minus 15, I'm going to get value like this, 23. Then 15 minus 15, 0. 26 minus 15, I have, that gives me 11. Now I do the other one again, I finish the second row, 15 again, 18 minus 15, 3. 15, 0. 2. 28 minus 15 gives me 13. Now I have the third one, 23 minus 23, I'll have 0 here. 53 minus 23, I have 30. 41 minus 23, that gives me, I have 18. So that's giving me 18. Then 36 minus 23. So that gives me, that's 6 minus 23. So that gives me 13 again. Now the last column, 14, 0, 23 minus 14. So I'll have 9. I'll have 30 minus 14, I have 16. 29 minus 14, I have 15. So I am done in doing what we call column reduction. So thereafter, I go now to do what we call row reduction. So how will I do the row reduction? So let me come here and check the values. So I have, let me find the minimum of each row. Alright. So you can see the first row here, after doing column reduction, the minimum value here is 0. So here I have 0. Here I have 0 again. So the minimum value in row number D is basically 11. So this one will help me to get my next matrix. Alright, so I'll draw another matrix here. So I'll have perform row reduction. Row reduction, so I have another matrix. So I have my customers A, B, C, and D. Then I have the engineers X, Y, and Z. So my new matrix will be like this. Alright, so this is my new matrix. Alright, so I'm trying to draw a better one. So alright, after doing that, now I have my new matrix in place. So let me perform row reduction. So I'm going to get every value minus the minimum value. So 10 minus 0, I'll have 10. 3 minus 0, 3. 0, 0, 0. 0 minus 0, 0. Then the second row, 23 minus 0, 23, 0, 39. Alright. Now the third row, 0 minus 0. Of course, the minimum is 0. So 0 minus 0, 0, 2, 18, 16. Now the last row, the minimum is 11. So 11 minus 11, 0. 13 minus 11, I have 2. 13 minus 11, I have 2. Then 15 minus 11, I have 4. So that's my new matrix. So I am done with the first step. Now I go to the second step, which says I cover the zeros with minimum number of lines. So in this case, let me check the number of zeros I have. How many zeros do I have? So I can see there are 2 zeros here, there are 2 zeros here. So the best way to do this is basically to identify a column or a row with minimum number of zeros. And you are allowed to cover either vertically or horizontally. So no one is going to restrict you on how to do that. So basically I can identify 2 zeros here. I have 1 0 here, I have 2 0. So I can cover this first one. Let me call this one my first line, line 1. Then I have 2 zeros here, so I can put a vertical line here. Alright. So this is line 2. Then I see there is still 0 uncovered, so I can cover this way or this way, whichever way I like. So I can cover it this way. So this is line 3. So in step number 3, we are checking whether the number of lines equal the number of assignments. So you can see in our initial matrix, the number of assignments are basically 4 customers, but the number of line here is 3. So M is not equal to 4. Basically what we are saying, M is 3. The number of line is 3. So that means we have not reached an optimal solution. So in this regard, we are going to perform step number 4. So in step number 4, we are going to come up with a new matrix. So I'm going to draw another new matrix. So I'll have A, B, C, D. Is my new matrix. W, X, Y, and Z. Alright, so I have my new matrix. Now in step number 4, we say there are 3 things that you need to do. The first one is to identify the minimum value which is uncovered. Alright, so let's go back to our matrix and see. So we have the values which are not covered by line. So you can see this is covered, this is covered, this is covered. So the only values remaining here is 2, 18, 16, 2, 2, 4. So the minimum value which is not covered is basically, so our X value here will be 2. You can see there is 2 here, 2 and 2. So all these other values are more than 2. So I have 2 as my minimum value. So the second procedure say, after identifying the minimum value, we add the minimum value to corner point, or basically where values which are covered by 2 lines. So let me identify. So the value covered by 2 lines is this, and then this one. So you can see 10 here is covered by this line and this line 2. Now I can see 23 also is covered by line 3, covered by line 2. So let me now add to those values. So I'll have 10 plus 2, that gives me 12. 23 plus 2, that gives me 25. Now the second procedure we said, the values which are covered by 1 line should remain unchanged. So you can see here, 3 here, 0 and 0, they are covered by 1 line, 3, 0, 0. So you can see 0, 39, they are covered by 1 line, 0, 39, they are covered by 1 line. So they remain unchanged. Now I can look at here also, I have 0 and 0. They are covered by line 2, so that's the case. Now for the values covered by, which are uncovered, we subtract these two. So we come here, 2 minus 2, 0. 2 minus 2, 0. 18 minus 2, 16. 2 minus 2, 0. Then I have 16 minus 2, I have 14. Then 4 minus 2, I have 2. Alright? So after going now, finishing the step number 4, finding a new matrix, the last thing is proceed to step number 2 again. So you go back to step number 2, where we're going to cover with minimum number of lines. And we check again, if the number of lines is not equal to final solution, we repeat step number 4 until we find a final solution in step number 5. Alright, so let's see. How many zeros do we have? So I can see 3 zeros here. I can also see 3 zeros here. So I can decide to cover it vertically or horizontally. So I can choose to cover these 3 zeros vertically. So let me just call this one my line 1. Now I can also choose to cover, so I have 2 zeros here again, or 2 here. So I can cover them like this. Alright, so let me say this is my line 2. Now I have 2 zeros here, I cover them. So I have line 3. Of course there is 1 0 here, I can decide to cover it vertically or horizontally. So I can even decide to do it like this. So I have, this is my line 4. So basically, for me to cover all the zeros with minimum number of lines, this one I have no choice, I'll get 4 lines. Now if, okay, sometimes people may find it difficult here to cover the lines, but to really understand by saying that you can either cover by horizontal and vertical lines. So you say vertical and horizontal lines is what you're going to cover with. And always try to cover with, cover maximum zeros. Don't cover 1 0 when there are 2 zeros which are not covered. So always try to cover with maximum number of zeros. Now because I can see that I have 4 lines, so therefore I can say M is equals to 4. So I have reached the final matrix, and for this reason I'll proceed to step number 5. So in step number 5 is final allocation. I'll perform what we call row scanning and what we call column scanning. Then thereafter I'll allocate a unique 0 in column and row. So let's see how we're going to do that. I'm going to come up now with my final matrix. So I'll say final allocation or final assignment. Final assignment. So I'll have my customers here. So I can say customers. So in my initial matrix, I had this customer, I had Bill, Alf, I had Bill, I had Charlie, and finally I had Dave. So I can also look at my engineers. So I'll say engineers. So I had all the engineers. I don't know. Then I have the distance. Distance in miles. Distance in miles. Of course, this one is in miles. All right. So I'll find my final allocation here. After checking that, so I'll be able to find total distance. Total distance covered by the engineers to serve the various customers. Now let me do now row scanning and column scanning. So let's see. So I start with rows. So you can see here I have 2 zeros, so there is no unique 0. Here I have 1 0 in row 2. So I can allocate this 0 here. So when I have allocated the 0, it means all zeros in that column and row are cancelled. So I'm going to cancel this. I'm going to cancel this. That means I'm going to ignore them in the next allocation. So I come to the second row. I have this already cancelled. I have only 1 unique 0 here. So I'll allocate this. Alright, so this is my unique 0. I go to the so if I allocate here, this column, all the zeros under it will be cancelled. You see now I'm done with this column, so the row also is done. I go to the last one. So you can see also here I'm finding my unique 0 here. Alright, so this is my unique 0. So I have allocated this. So then the 0 here is also cancelled. Automatically this, when I do column scanning now, I'm done with row scanning. I do column scanning. So column number 1, there is no 0. Column number 2, all zeros have been taken over. Column number 3, all zeros are taken over. Column number 4, there is 1 0 here. So I allocate that 0. So you can see therefore that I have done full allocation based on that. So remember also, you can start from columns to allocate, not necessarily do rows like what I've done. So you can start from columns, all right? So finally, we can find our final allocation or assignment. So I have W is assigned to customer C. So Alf, okay, let me start with A. A here is established to Z, all right? Then in my initial matrix, of course, I can see the distance between A to Z is 14, all right? So I write 14 here. Now you can see B is assigned to X. So B is assigned to X. Then you can see the distance in our initial matrix. B to X is 15. So I can write 15. Then I can see Charlie. Charlie here is assigned to, in my allocation here, is assigned to W. So W, distance in our initial matrix. Charlie to B, so we have 15. Finally, we have the last one. The last one here is Dave. Dave, you can see, Dave is assigned to Y. So you can see Y here. So Y, you can check the distance in our initial matrix. Dave assigned to Y, so that's 6. All right. So you can tell me how many miles in total were covered. So I add 14 plus 15 plus 15 plus 36. This one gives me 80 miles. So we have come to the end to our assignment problem part 1. See you in our next video.